to this scene. I hope you've all had a great week. It's a good Friday. I let myself sleep in today because I have the day off. And so I can do maybe a little bit longer stream than normal. I'm thinking of going to about noon for me, which is a couple hours, a few hours. I might have a break in there in the middle, but also we get to start playing with chapter 3 of the Nature of Code. So where we left off on Wednesday, let's take a look at that. So this will be sort of the ecosystem project here. And what I ended up doing was we had fixed the walkers don't disappear when eating each other, and I was attempting to like have this entire last walker alive wins thing going on. And I, after thinking about it, ran into a little bit of problems with it. I decided maybe waiting until the very end would be, more helpful for that. I also put my create screenshot for thumbnails into here. I might do that off screen, or maybe just like eventually again at the end. For right now, I think what we have is good enough for us to say, okay, chapter 2 is done. Let's move on to chapter 3 and get some of those interesting like things going there. So let's run this and I'll show you what it looks like. So the biggest change, the food now is randomly sized. So we can go between 1 health, 1 pixel, and 5 pixels radius. And the random walkers, there could obviously be tweaks to their speed moving around. I have the attraction walkers, the ones that like choose a piece of food and move towards it at all times. They're pretty slow, and I have that for a reason. They always will guarantee to get some food, whereas the random ones may not actually find it. And then it just sort of runs until I decide to quit it. And I think that should be perfectly fine. Looks like we only have 1 random walker left. Oh, nope, it just got eaten by a giant purple color ball. Oh, now it's chasing this smaller one, it looks like. But it going into the corner won't help. No. There it goes. And we have a winner there. So that's the ecosystem project. So what I'm thinking is I can make a cut there. So I can do something clever. Come over here, go to the dashboard. I can. Oh, there's no ability for me to put in I think it's marker. Marker and what is it called? And ecosystem. All right, so now this can be beginning of the next video. So the next sort of archive video that we're doing here is Nature of Code Chapter 3. And of course, the code that we're doing is all uploaded. I'll have links to the description. Down if you're watching this on Twitch, in the description of the channel, I have links to all the repositories, and specifically Nature of Code. We were in the ecosystem folder, and now we're going to be in chapter 3. So let's go ahead and start setting that up. I keep have to look over to the right because my main screen is over there, and when I'm like alt tabbing, it is like the window for like what I'm selecting is way over there, which I mean I'll have to figure out some like better way, or maybe just like accept that I'm constantly looking over to the right. Okay, so we're done with this. This is all pushed up. Close you. Let's create chapter 3. And now, well, I've got the physical book, Nature of Code. It's going to be a lot easier for me to use the digital copy of this. So if you're following along and you want to like read this book yourself, this is Nature of Code by Daniel Schiffman, natureofcode.com. And you can read the entire book for free online. So you don't have to purchase a copy of it. I ended up doing that because I just like to have a physical copy when I'm myself like going through these and learning. We're on chapter 3, oscillation. And this is going to be all about like rotation and angles and movement like that. And our first exercise here is this idea of creating a baton-like object and then rotating it around the center. And I think what's interesting is that they're creating, I think, like a square. And then they're putting the baton, so let's pause. They're putting this line, and then with 2 circles in the very end, and then they're rotating the entire object that it's inside, through around the center. For us, because we're not using processing, we're using GGEZ, so we don't have exactly the same functions available to us, but I think we can get something similar enough to this. So that is what we're going to do. Exercise 3.1. Rotate baton. So I'm going to cargo new exercise 3. I'll just do 3.1. Yeah, I think that should be good. So we'll CD into it and open up VS Code. I need to increase the contrast of my display because it's really dim. All right. Okay, so we have all the basics of what we've got here. So I'm thinking we're gonna bring in our BBGGEZ. Coding Garden, good morning, hello. So we want BBGGEZ. What extension do I use to show my GitHub info? Oh, the one down below. I can show you. So on my dashboard here, is Twitter timeline. And then what's really sad is it's not showing the GitHub one here, but that's GitHub. Sorry, yeah. Let's add it. No, yeah, it's only extension there. I think. Let me see if I can find. Twitch.tv, go to my, hey, no sound there. Go to my dashboard. Oh, yeah, it's only the Twitter one shows up in the old dashboard too. I think then I could probably just go to my page. Oh, come on. Pause. Yeah, so if I show this, this is my page, and then if I edit the panels, it is a GitHub profile. That's what I'm using. Yeah, it like this is the only one that that didn't seem to require any extra permissions when I was trying to use it. So I definitely enjoyed that. Come on, mouse. Work with me. All right, so close you. We're creating this here. So back to you. BBGGEZ, the latest version is still 1.0.0. And then the other thing is we need, we need to bring in specs. So specs equals, and then I remember it's like something like version equals 0.15.1, I think. But then there's like extends or something. I already forget what that is. Thank you. I got some tea delivered. It's all hot, ready to drink. Perfect. All right, let's go to the documentation and take a look at what that needs to be. So specs at Amethyst, docs. It's funny that like Amethyst is moving away from specs, but that's the location of where the book is. So I hope they don't make that go away. This is what I want. So it's gonna be version, and then features equals, and this specs derive. So I can just copy this entire line here. And we want the latest version. Hello, good morning, Chantilly. Happy Black Friday. Yes, if you are in the United States, and that's something that you do, good luck on getting whatever deals you get. I've known some people that have been able to get some nice things. I usually don't even try. I just stay home and avoid all the crowds and everything else. Okay, so we have you all. So I'll let RLS go. Let's go ahead and connect our Twitch highlighter. Yes, lots of shopping. If that's your thing. All right, so with that, let's go ahead and create like our empty basic shell of a program here. So that's going to be in our main. We're going to bring in, oh, you know what? Before we even do this, we do need our library to create our at least basic, what is it? We need our basic sort of like game object, a game structure. So we're going to have a pub, I guess like game, pub struct game. Nothing in it right now, but we'll implement game pub function new. I'm not going to take anything in right now, but we're going to return a new game and game. Like that. That's all I need to begin with in here. So I just need to use this. So use, this is exercise 3.1 game. And then we also need to use bbggz and run. I think we can, so do we want to run dimensions or just run? I think it might just be run for right now. I can't remember if I want, like, I care about the dimensions of this. So in here, oh, not that, there. I'm going to run, so the game. So I need the, need this, so that mute game equals game new. And you become our reference to our game. We have our title. Oh, do you need to be mutable? Yes. Mute reference to game, our title. So this is going to be well, actually, it's not exercise. That's the name of the other thing. What is the title of this exercise? It is rotate a baton-like object. So rotate a baton like object, and then the author is me. Xerker. Run, I don't think it doesn't return anything, so it's just semicolon, and I think that's it. Right, and so the traits that we have in here are not handled yet, so we need to add that in. So let's go ahead and bring in use bbggez, ggez. We know we're gonna need event. I think it's event handler as the trait that we're caring about right now. We also know we're gonna need context, game results. That might be it. All right, so let's implement event handler for game. And we're gonna have function update. And we're gonna get in a reference to context. What they're missing here is mutable self. Reference to context. I'll just let this have the warning for right now. So context, and then we're gonna return game result that's empty. And that way we can just run right now, okay. And then we're gonna have function draw. So this also brings us mute self, context, and we're going to return a game result. And so here's where we're going to set like whatever the background color is going to be. I've been doing a lot of black recently. Should I continue with the black background? Or should I do white background, or maybe some other color? We can try white, see how it is. So we're going to have we need graphics. So graphics. So graphics. I think it's like clear, and then it's a color. So we hand it the context, and then the color. So we can do graphics. How about an aqua background? Ooh, that could work out. Do you have a preferred RGB for that? What is it? Color, maybe like color swatch, aqua. I was hoping for RGB. Oh man, these are all hex. Is that RGB that they have there? And with slashes? I think it is. It's a little bit interesting. I'm gonna choose maybe like this one. 168, 222, 207. So what I can do here is create our color. So we're gonna call this the background color. And this is gonna be a graphics color. So let background color equals, we're gonna graphics color it's not new, it's from RGB, yes. From RGB, the alpha we're not gonna care about. And so now this will give us a 0 through 255. So we had decided 168, 222, 207. So 168.0, 2.0, 107.0. Background color goes into here. You're new to Rust. What's colon? Yeah, so colon is, so notice here I have this function new. This is a method that's, you can almost like imagine that they're kind of like classes, if that's what you're familiar with. As here's a structure, so it's going to be like, we're going to instantiate an object from it, and then new is a method for that object, but it's not something that I instantiate and then I use dot with that to run it. Instead, I'm going to use this colon, just like I do over here. And that's because new is a static method off of game. And that just means that it's available all the time directly off of the structure. These other functions that we have, they take in this mute self to begin with, and that means they're going to be executed somewhere, probably in GGEZ, with the dot, with just dot notation. So it'd be like game dot update. So that's how that works. All right, so what are you upset? Oh, it's U8, not F32s. So I can make you go away. So here's a color. We're going to store it inside of our structure here. In draw, we have access to that with self. So context, our color will become self.background color. Clear, what do you return? Nothing. Semicolon. Maverick Twitch, good morning. Hello. Right, you're upset because we haven't returned anything. You tried to install RustUp. Did it not work? It showed linker failure. Oh, interesting. What kind of system are you on? Is it like Linux or Mac or Windows? And then, oh, we need graphics present. Then we hand it the context here, and then I'm not going to semicolon this. Windows. Oh, you know what? So I haven't played with Windows 7 in a long time, and I've definitely not installed Rust on that. And I'm guessing the Ubuntu subsystem for Windows, is that Windows 10 only? Yeah, I don't know about Windows. That might be a tougher one. If you can get like somehow like maybe, well, you can't use GGEZ inside of Docker because you need like the actual graphic stuff, and Docker won't pass those through. So I guess you could use, like, if you can't figure out how to get it in Windows, you could use a virtual system, like what's the really popular one by Oracle? VirtualBox. Install Ubuntu that way, and then just just run it inside of there. Like, not super awesome. I mean, I prefer Linux for this type of stuff. All right, what are you upset about now? Graphics present context. Expected struct game found enum standard result. Oh wait, we're not returning a game. We're returning a game result. You'll install Ubuntu? All right. I think that'll be a lot easier to get Rust going. At least it was for me. I just ran the script that they had and it installed. All right, so this should give us our base game here. Let's go ahead and run it. So cargo run. It's going to have to compile everything at least the first time. You hope you don't get an error. Well, if you install through VirtualBox, then it's not going to be that much. It's not like installing the full operating system like on your computer, dual booting and setting up anything like that. How about install to a higher window operating system? Oh, you mean like upgrade to Windows 10 if you can? I don't know if your hardware can support that. Windows 10, like I'm running it on my my streaming PC, and it's been getting better and better. You don't like Windows 10? Well, that's a good reason not to run it then. Hopefully you can get this working. All right, we're almost through with the installs here. Well, we're almost into here. How is everybody doing? I usually tell you about how I'm doing, but I don't usually get too much to ask like how things are going with you. So let me know. In the meantime, it looks like that doesn't look like the aqua color. I think I messed that up. You tried to run some software using Wine in Ubuntu, so switch to Windows 7 because it didn't work. Oh, well, yeah. Wine, like if you need Windows stuff, like Wine is really tough. It works sometimes, and when it works, it's really great. When it doesn't work, it's sort of like, I hope you have another system that has Windows. And I know that's one of the reasons why a lot of developers have switched to Mac, because you get best of both worlds. You get the Unix backend system you can install Unix things on, and you can also get like all the Microsoft products, and everything that runs on Windows usually also runs on Mac. Yes, this looks green. This is because it is green. It's not the color I was going for. I guess now that I think of it, that is a little bit green, isn't it? RGB, yeah, that's a heavy green. We could try 103, 196, 193. That might, well, if I go down to like something like this might be better. It is overpriced. Well, I mean, yeah, that's is the eternal problem, right? Like what we want is not always like available to us in the price that we want. Which is why I don't have a Mac. I've been going Linux because it's a lot cheaper hardware. And then I do have an older Windows computer for running those, like for running games that I like obviously won't work on Linux, and streaming because OBS is okay on Linux, but not great. So let's try this again. So I'm thinking 128, 207, 216. Save, and we'll run this again. Hey, there we go. This looks a lot better. How does this look to you all? And I think I can move it around like that. So perfect. All right, so what we want to do now that we have this, so I'm going to go ahead and close all these windows. Let's go ahead and get a git commit going here. So this is going to be created basic canvas, and push that on up. So what is our challenge for this? We want to create a baton and then rotate it. So I guess like the first thing we want to do is just create the baton. Now, in this example, what they're doing is they're creating a baton with a class, I think. Where is the? I don't know if they have the code here for that. They sort of have it. I guess they're not using a class in this one yet. So they're basically saying, okay, we're gonna create our angle velocity, our angle acceleration, the gray fill. Oh, so they're making it increase in velocity constantly. Be right back. Okay. To do stroke 0. Okay, so that's gonna be black. Now they do this thing rect mode center, which we don't have in GGEasy. Translate. So they're gonna move. So they're gonna create this over here in the upper left corner and then move it down here into the middle. We have a line. That's the line between them all. Let me pause. That's this line between them all, and then 2 circles on either side. And then they just increasing the angular acceleration and then the angle. And then that's this rotate by that. So let's start by creating our baton. So what I'm thinking is we're gonna store. Well, it would be really nice if I could store the mesh inside of, or what is it called? As a resource inside of specs, but I don't think it's that big of a deal. Like, we're not going with like millions and millions and millions of these things right now. So I think just storing it in this main game state here will be fine. So let's go ahead and we're gonna say so our baton mesh is going to be a graphics mesh. And I'm almost thinking that we can have a function that will create this mesh for us. We could, we could just do this here. So I could just do like let baton mesh equals, this will be graphics mesh builder new. All right, so what do we have here? This is also going to be different than processing here because we can create a single mesh that has all the elements together. So we know that there's going to be a 2 circles. So I could just begin by saying, okay, we're going to have a circle. We're going to have a draw mode. So that's going to be graphics, draw mode, fill. We're going to have a point. So like, where does this exist? So let me go to the whiteboard. So what I'm thinking of is we're going to have like a line like this, and I'll probably have it horizontal to begin with, and then a circle and a circle at the end here. And in order to make this have like the equivalent of that rect center or like rect mode center that we have in processing, I'm thinking that I want to cut everything in half here. So the circle normally will be like in the center right here. I need to figure out how wide this entire baton is going to be, and then have this center be to the left of it. So let's say if I arbitrarily decide this entire thing, that's out of scope. Let's do it down here. If this entire thing is like, I don't know, 300 pixels. And let's say my radius here is going to be like 50 pixels. Then I'm going to say I want to go half of this length, so that would be 150 plus the radius. So that's what I'm going to do. Okay, so if half the length over there, we can create some variables to help out with this. So let our, what are like the things, like the circles in the end of the baton, what are those called? I guess I could just call this like our circle radius. Our radius, this is gonna be 50.0. And then we're also gonna have like the baton pole length. So let pole length equals, this is gonna be 300. Dot 0. I'm using F32s for this because that's what GGEZ needs. All right, so we have this radius, pole length, baton mesh, baton cap. I don't have anything else, so I'll do that. Maybe cap size, cap radius. Okay, so what we're gonna do is we're gonna say circle mode our point here. I don't need to use a vector 2 for this because we don't, this is never going to change. In fact, it's going to stay in this position for its entire life. So we're going to bring in NL, not there, in this here. We're going to bring in NAlgebra, 0.2. And that will allow me to say here, 0.2 new. So the x for this, that's going to be in the center minus. So that's the halfway point. So what is that? That's pole length divided by 2.0 minus, and that's going to be the cap radius. I think this is also going to be minus, like divided by half, but it's just the radius also. So I want it to like go halfway over. So I think that's going to be fine. Then we have our radius. So this is our cap radius. We have our tolerance. Tolerance is like how long between each spot in the circle to draw. So this just needs to be a small number. And then color. So what color does this need to be? So let cap color equals graphics color. We can do another from RGB. We need to figure out what color our cap radius could be. Should I make it black? Should I make it gray? Sort of like how he had, how Nature of Code does it. I don't know. Red, green, blue. I don't know what would work with our sort of aqua color that we have. If I set this up as like 200, 200, 200, it's like just even all the way across. Neon pink. I don't know if I like that idea. Something neon. I don't know, like I don't know if I like neon colors. I think I'm going to veto that one. Unless like if you can come up with a neon color, I'll try it out. So like send me an RGB and I'll give it a shot. Okay. So this is 200, 200, so cap color. So this is going to be our cap color. And so this is just our the first circle. Then we have our line. So dot line. And this is points. So like from where to where. So well, we know that the first point is that one on the left. So, and we see that over there on the left to the right. So we're gonna say, this also looks like a vector of an array of points. So I think I can just do a straight up array of point2 new and going to the left, this is going to be the x is going to be our pole length divided by 2.0, and I think that's it. And that's, let's see, length divided by 2.0, and then 0.0. So we're not caring about that. I think I missed that with this other point 2 new. We're gonna stay in like the top left and just like, there's no height to this at this point in time. We're gonna take care of that by translating. And then our next point is gonna be a point 2 new. And this is gonna be, now that I think about this, this needs to be 0 essentially minus our pole length divided by 2. You found a sort of like red color. Ooh, okay, I'll try it. 178, 87, 122. Or orange. I'll try the orange for like whatever next thing we want to do. All right, so this should be like negative number. So to the left of the center point. This other point needs to be to the right of it. So it's going to be, this is going to be the pole length divided by 2.0, 0.0. So those are 2 points. We have our width. So how wide is this? Let's do like, I don't know, 5.0 just in case it's too wide. And then our pole color. So that pole color equals graphics color from RGB. We'll do 246, 177, 127. That orange color you found. And this will be the pole color. Okay, so that's the line between them. And then we're going to have another circle. Okay, so oh, interesting. Take a look at this. So circle just returns itself. Line, however, returns a game result of itself. So I have to do question mark here. Oh no, I have to unwrap here because I'm not returning anything potentially. Unless I like return a game result, which I could. That would allow me to, so if I do game result of game like this, that allows me to question mark this. Now, circle now works again. So draw mode again. This is actually going to be exactly the same as this other circle, except the position is going to be different. So graphics draw mode fill. so instead of the x to the negative side, this is going to be the positive side. And then everything else is the same. And at the very end of this, we're going to build, hand it, context. We don't have context available to us here. So we can't do this right now, which is, it's sad. So what this unfortunately means is I'm going to have to wait until either the first frame and then handle this in update, or change how my main function is working so that I can pass context in here. So if I say that I'm going to get context, which is a mutable reference to context, now I can pass in context, and I can question mark this. It's not really neon. Well, then perfect. Okay, so that gives us, you're also colon. That gives us our baton mesh. So I want to store this in here. Our baton mesh. We'll save. Oh, that's fun how it like auto refactored that. Also, you're very upset, right? Because you need to be a 0.0 to be F32. Uh, 0.0. This needs to be a game result. So this is now going to be a game result. Storing this. Actually, it's okay. That's all it is. And so I don't think I can pass it just a reference to a literal. Oh, okay, I can. Now, the problem here. Yeah, so it's not being used. I guess I'll handle this problem later. Let's go ahead and just like draw this to the screen. So we have the mesh right now. So we're gonna just do graphics, draw, hand it the context, and then a reference to the drawable. That's self.batonMesh, and then params. So this is gonna be graphics, draw param, new, and these are going to be like the default param. So I'm just going to accept that for right now, and question mark, which returns the game result, and that should be good. Now the problem here, of course, is in our main function, we're not passing in the context to the game because we don't have it. So we need to go to GGEZ. And here's the basic project template, and we're just going to use this. Actually, you know what? Now that I think about it, I think I can just get away with gmain, which is I just created this earlier for myself. So let mute conf. Okay, so yeah, we need to do all this stuff here. I'm gonna go ahead and delete this up to here. Okay, so conf new. So I need to bring in use bbggz. Actually, I can just use the same one up here. Okay, so we're gonna bring in gggz and conf. Where does conf come from? Oh, is this new? Have they updated it? They may have. I'm just gonna take this, copy it. Katali, good morning. Are you too late? No, absolutely not. Never too late. All right, so we're gonna make our context. What we've done so far, Katali, is we've moved on. Like I just explained that, like I'm pretty much done with the ecosystem project for chapter 2, and then moving on to chapter 3, which is angular momentum, or oscillation technically, but angular momentum is their first example here. So I will need you in a little bit. I will ignore you for right now. Okay, so make a context. And then event loop, that's interesting. Context builder, new. So this is gonna be angular, is it angular momentum? Angular motion using rotate. Angular motion using rotation. This is me. We build, expect, could not create that. We then have my game equals, this is gonna be a game, new, and then here's where you're gonna pass it in this context. That's how we get that in there. Sounds cool. You've been absorbed with a Go proxy that you're building. Oh, awesome. How are you enjoying Go? I haven't played with it, but I know some people who use it and they love it. So we're gonna match event. Okay, so we need event off of here. So match event run, pass it in the context, our event loop, and my game. So you're upset, right? Because our new game, we have to unwrap here because we're passing it a game result. I have to try it someday. I just like, I love Rust too much to like switch over right now. But yeah, someday I'll probably will. Context builders, we need that. So context builder. Okay, everything is in here. That gives us our game. Run is gone because we don't need that anymore. And no errors, just that one warning. So let's go ahead and run this. Hey, and take a look at this. We have half of a baton. Those end caps are really huge compared to everything else. I think I should make them a little bit smaller. But this is good. Maybe before we do that, let's move it over into the center. So I want to the way we're going to move it over to center is not by changing the location up when we create the baton. Instead, what we're going to do is in our draw params, we can set a destination. So we can, but in order to do that properly, we also need to know what the arena size is, like what the size of our canvas is, so we can like figure out what true center is. So let's do that. We're gonna say let width and height equals, it's gonna be graphics. What is it off here? I always forget. And I have to like go and look at it. Is it drawable size or screen coordinates? Screen coordinates returns a rectangle defining the coordinate system of the screen. I don't think I need that. Size returns the size of the window in pixels as width height, but this includes borders title bar, so I don't want that. Drawable size returns the size of the window's underlying drawable pixels as a tuple. That's what I want. Drawable size, pass it context. Do you just return a tuple? Thank you, Katali. Drawable size. So then our width here. So now I can do off of our draw params. We're going to say a dest point to new, and so our x is going to be our width divided by 2.0, and our height divided by 2.0. And I think this should put it into the center. Sort of. So it's not exactly in the center of the screen here. It's slightly offset to the left. So I think my math must be slightly wrong. Or it is in the center. So if I turn off the circles, if I don't have these, and I just have our line, is that in the center? Okay, the line is in the center. The I'm not putting the circles, the end caps, in the correct spot. So let's do the left one first. We want this to graphics mode 2. So it's going to be half of the pole length as a negative. So like less than 0. So that's negative pole length minus cap.radius. And I think I need to make this multiplied by 2.0. Oh no, okay, so not negative, not times 2.0. It's just the radius. All right, and so now I need to do the same thing and create this one over here to the right. And that is you. Okay, so our pole length divided by 2.0, so that's going to be the number to the right. But we need to not minus cap radius, we need to add the cap radius. That was our problem. There we go. This looks so much better. We can also make these caps a lot smaller. So I have cap radius like 50. I think I can just make these like 10 or maybe 15. And our cap, our pole sort of width, we can make this a variable here too. If I do something like 3.0 instead of 5.0, I think that'll look a lot better. There we go. So our challenge here for this is now going to make this rotate. And so we're going to create our angular momentum, our angular velocity, and I guess like I'm just going to continuously increase that and then use rotate to rotate it. So in the meantime though, I think I've been streaming for an full hour and I still have some time to go. So I'm going to go refill my drink And then I'm gonna be right back. So while I do that, we can watch the original Nature of Code ecosystem game. Ecosystem cargo run. All right, I'll be right back. Well, that went a little bit crazy. But I mean, I think it's uh, a cool system for like displaying things. It's too bad I can't have that running on a web browser, but like maybe I can compile that for Windows and like make it like a full screen game that's showing. But I should probably cap the size uh, so it can't get like bigger than the screen because when that happens, it goes a little bit. It does get a little bit crazy as it's trying to like reposition itself. But that's a future problem. Let's continue on. So back to here, um, we have our baton. I want to now give it our angular momentum, and I'm thinking we can use specs for this. We'll create one to begin with, but then of course I always try to like put 100 of them on the screen at the same time. So then we can have a little bit of fun with it after we build that. So let's go ahead and create. So we're already using specs, so we can use specs. What is it? The component. And I need world extension, and dense vec storage. I think that's all I need for like the super beginning part. All right, so we're gonna derive component and struct. So we're gonna have positions like where this is, and that's where we're gonna translate it to. So instead of this entire like position here that we're gonna do, it's going to be the Well, actually, do I really want to use specs right now? Probably not. I'm thinking I'll use specs as soon as I get it rotating, and then I want to get like 100 of them on the screen. That's what I'm gonna do. So I'm gonna just comment you out. I will come back to you. So let's begin with, we're just doing a single one. So we want angular momentum. So angular location? Is that? I guess it's just angular. We're gonna have our angular velocity and our angular acceleration. And then we're gonna increase our angular acceleration constantly, so it just starts spinning faster and faster and faster. Okay. So our angle, this is gonna be an F32. This is gonna be angular velocity. This is this one we're gonna want a vector 2, or is it really just gonna be another F32? Because like if we have this here, yeah, angular velocity is just a single number. It's just a scalar. And then our angular acceleration, so angular acceleration, this is going to be a F32 also. We'll probably eventually want to cap the speed, but for right now, we'll just let it go until forever. So let's create our new one here. All right, so let angle equals 0.0. Let angular velocity equals Andrew Lane. Good morning. Hello. This is going to be our we're going to start with this. It was 0.02, and then finally let angular acceleration. And we're going to have this be 5.0. I'm just sort of making just choosing these numbers randomly. We'll have to tweak them to get exactly what we want. And now we're going to store them all in here. So angular velocity, angular acceleration. Now, when I draw this, we have a destination here, and also we're going to now have a rotation. So dot rotation of self dot angle. Oh wait, that was the point. Wrong spot. Here, dot rotation, and this is going to be self dot angle. What am I making? I'm following along the Nature of Code book, and I am on chapter 3, oscillation. So I am making this, which is a baton that's spinning in the center, and it has angular momentum, so it's going, or an angular acceleration, so it's going to spin faster and faster and faster. And so that is what we're trying to make. So right now, I don't know if I've saved it. We have the baton that's sort of sitting here in the center, and that's it. So we want to do, so self dot angle, it's not rotated yet. I want to now increase, so in update here, we're going to increase the rotation angle. I guess we're not using this. I'll just underscore that so we stop getting that warning. We're going to update the angle every frame. Oh, you know what? I'm about to need context because I'm going to need timer. In order to get the delta time. So let's go ahead and get delta time. So delta time equals timer delta. Get the time between the start of the last frame and the current one. Okay, and then we're going to pass it context. And this gives us a duration. And so I need to get the duration as an F32. So let's kind of like do, as sex F32. And now I'll multiply this by our angular acceleration to sort of change that. So now we're going to say self dot, so we're going to update our velocity. Self dot angular velocity plus equals, and it's going to be self dot angular acceleration times delta time. And then self dot angle plus equals self dot angular velocity. And so this should hopefully make it start spinning, and hopefully not too fast. Oh, that's far, far too fast. Even when I apply the delta time to it, that was just too much. So if I set you as a very small number, like 0.01, let's say. Oh, that's still too fast. It is spinning though. You may need to map it between 0 and 15, for example. Map it between 0 and 15. The angle or the angular velocity? Well, I mean, yes, it is working. It's too fast. I'm multiplying it by our delta time, but that's still too... Do I multiply it here or do I increase the angle by that? I don't remember. Angular velocity. Map between 0 and 15. Well, because like I think it can go up above 360, but it will still like the graphics card will still figure out how to like how much to rotate it by. I think that's how it works. If I just make this a really, really small number. Well, I see it turning very slowly. Capping the speed might be good. This is maybe perhaps a little bit too slow. Okay, I think this is a little bit better. So we start nice and slow like this. It is spinning along the center axis. Maybe capping is more appropriate. Oh, capping our velocity. Yes. Okay, yeah. I get what you mean. Yes. I guess like I don't think of map in that way. But you're right. Capping our velocity so it can't go over a certain amount would be really good. And I don't know what that would be. We could print out what our angular velocity is, so we can, like, once it gets too fast, we'll just, you know, slow it down. Light speed, yeah, cap it at light speed, where, you know, it's so fast that we can't tell. So, I mean, I think we've got this. Let's go ahead and I'll leave that running here. Then we'll cap the speed. So we're gonna want a max speed here. So angular velocity max. This will be an F32. So again, I don't really know what to set this to. We can set it to, like, I think maybe like 3.0 is fast enough. How about lots of batons? It'll look like lots of, yes, that is actually the plan, is to have lots of batons and have them flying around. Okay, so angular velocity max equals this. Let's store that. Angular velocity max. We're going to come down here into our update, and so we're going to increase our angular velocity. But before we increase the angle with the angular velocity, we need to now, like, to set that to cap it. So self dot angular velocity. You may create a double pendulum in this chapter. Those are really cool. Oh, is that where it's like one pendulum coming like that and then another pendulum off of that too? Oh man, yeah, that sounds like pretty fun. This also sounds like very math heavy, so it's gonna be the thing I'm gonna have the most problems with, but also I have a wife who knows math really well, so I'm probably gonna rely upon her a lot. Okay, so we need to cap. This is where we're just going to say if self.angular velocity is greater than self.angular velocity max, then I want to say self.angular velocity, let's just set that equals to self.angular velocity max. All right, so that will cap it. So we don't just, like, continue going forever and ever and ever. Save that, and let's go ahead and run this again. I can create this going really fast already, like a much higher angular velocity, initial angular velocity. We do 0.1. Yeah, look at this. Like, this is at 0.1, it's already so fast that it's pretty insane. I think to help out with displaying this, I'm going to print what our angular velocity is. So let's create our text for this. So I guess it's just going to be the text. I think I can do that. Okay, so let text equals, maybe we'll just do this. Angular velocity text equals graphics text new, and then a fragment. So we're going to do the format macro. And we're going to say angular velocity. And then in here, that's going to be self dot angular velocity. I don't think new returns, yeah, it just returns the text. So now, okay, so angular velocity text equals this. I can now draw this out. So graphics draw, pass the context, the drawable, so that's a reference to the angular velocity text, and then the params, this is me graphics draw param new. And so dot dest .2 new. So I'm thinking like just top left corner. So this will be like 5.0, 5.0 pixels down. And then yeah, color. Yeah. Dot color. Yeah, I think that's what I care about. I hate like VS codes. No, that's not right. Okay, so graphics, draw param new dot dest. So this is all in draw. Draw parameters. Okay, so if I save you, I think it's dot color. Color is next to dest. That's what oh wait. So draw is here. Did I lose a parentheses? There we go. Dot color. Okay, so color, and this will be graphics. Let's just make this black. There you go. Thank you, Katali. Save you, and I think. Oh, come on. Graphics black, and then draw. We need to question mark it. Semicolon. There we go. I was waiting for the Rust format to like auto bring it down to multiple lines. So this should give us our angular velocity. And so if I start you as 0.00, and we have a max of like, I don't know, 5 is insane. But we can now watch it go up and then like just keep in mind what our maximum should be. Like it's already getting decently fast and it's 0.01. Amir, good morning. What am I using for the rendering? I'm using a game engine called GGEZ in Rust. I feel like this might be the good place to cap it. Like 0.03, maybe 0.04. Because like it's getting pretty fast at this point in time. So our cap speed 0.0. Let's just do 0.05. So cap that. At 0.2, it starts with rendering issues. I mean, at this point in time, I'm seeing rendering issues right now. at 0.2? 0.02. Yeah, okay, so we could just do 0.02 to stop rendering issues. How about that? So turn you off, turn you back on, but this time with no rendering issues. And I'm betting, like, I'm wondering if there's other game engines, or if I'm doing this in release mode, that I'll be able to get better, like, less rendering issues. There we go. Angular velocity has been capped, and this is where we're at. All right, so I think this is pretty good. We've got it capped. We've got it just in the center here and spinning around. So I think that's enough for us to create a git push for this. So we have a spinning baton capped rotation. Okay, so we have that. Let's well, clearly the best thing to do would be to create a lot of them. And here's what I'm thinking. Create a lot of them, start them off of the bottom of the screen, and sort of like shoot them up while they're spinning, and then they'll fall down again. And then they'll disappear and like maybe create another one. So that's what I'm thinking. So let's begin. So we're gonna use specs for this because I'm gonna want a lot of them. And maybe like generate like one every frame or something crazy like that. And so, or at least until like we run out of frames, like until we go below 60 frames per second or something like that. Okay, so let's bring in, you want to left off? No, not that. You. Come on. There we go. Shall we make some specs utilities in BB GGEZ? Yeah, I think we should, because specs is really awesome. I think we're gonna have a lot of fun with it. Also, what happened here? I somehow like got a main in my library. Okay, so what are we gonna need? I'm gonna want, so like, let's say at the beginning, I'm just gonna create a whole bunch of them on the screen at the same time in random spots. And maybe like every second or two, we're going to like create another one and add it in. So, you know, put it on the screen. So if I do that, we want a location. So we're gonna have a derive component. We're gonna have a struct location. And this is gonna be a, we don't, well, I'm thinking we're gonna want to make this a velocity, like instead of a 0.2, a velocity, because we're gonna actually move these around. So, oh, sorry, a vector 2. So I'm gonna go ahead and close these functions down to make it a little bit easier for us to deal with this. All right, so let's see, I can close down even more. That, yes. Okay, so struct location, and this is going to be a vector 2 of f32. We can have an impl for this. pub function new. Gonna return a location, and we're just gonna return a location of vector2 new 0.0 0.0. Do we care about that? We probably actually want to create these in like a random spot somewhere in the arena. So what if I just take in an X, F32, and a Y, F32. And this becomes new X and Y. Drinker time, drink reminder. I've got a drink. Also, drinker time, good morning. I've seen some bots, like some other streamers have. This is tea that I have. But thank you for the reminder. It's also good for warming me up because it's really cold in here. I think I might want to turn on my space heater because I have the other one in the room off. Did I say hello to a bot? I did. I mean, I'm assuming it's a bot because I did not set up that as a bot for myself. So someone else maybe is like pointing it at me. I don't know. I'm gonna turn on a space heater though because my fingers are getting cold. All right. Yeah, it's a bot. Drinker time is the bot, which I have no idea whose bot that is. Implement, right. With these type of structs, I need a semicolon. Someone should have used bang join at Berserker in its chat. Oh, yeah, I guess that would work. So then in our game, to add this in here, to give our baton a location. So we're gonna need a world. So we're gonna have our world, and it's gonna be type world, and implement on game in our new function. So I can close all these down. We're gonna say let world. I think this is a mute world. Let mute world equals world new. And we're gonna say world dot register colon, and this is gonna be the type here, so that's gonna be our location, like that. I think that's how it works. It's been like only a couple days since I've used this. And then we're gonna create our baton. So we register the component. Oh, create entity. So world dot create entity, like that. Oh, come on, auto. Fine, I'll put world in here like that. Will you now give me? No, you won't. Let's go take a look at the documentation. Okay, so world.register. I've got that right. And then here it is, world.create entity, oh, .width. So I need width. too. Oh, that's with the world extension, I think. So create entity dot with, and then I just add in these positions. So we're gonna have a location new, and then I gotta say like wherever I want to be. So let's not put it in the center so we can see it actually come in somewhere else. This will be like I don't know, 500.0, 200.0, and then we're gonna have a dot build like this. So save that. And then we have our location, our width. Oh, entity builder. Builder like that. There we go. Okay, so we have a single baton in specs, its location. We also need to now move all of the like angular momentum stuff into here too. So if we take a look at what we have in update to begin with, and even if I don't have update, like even if I only put the draw stuff in here, destination, so like we need the draw system. Let's go ahead and create that. So struct draw system. So impl, we need system. So impl system for draw system, type system data. Is that what it was? Yeah, system data. Oh, equals. And here's where we get to use a tuple of interesting things. So we're going to have a read storage. Read storage. Is it colon? No. Of our location. And that's all we really care about here. Now in draw, we're going to need the mesh. Wait a second. This is weird. We need that. And then no, not that. There we go. Okay, so struct draw system. In here, we're going to need a context, and this is going to be a mutable reference to the context. So that's going to be fun. We're going to have a lifetime for that. But that's all I should need for there. And then I need to do the exact same thing for the mesh. So baton mesh is a reference to a mesh. Cannot find, oh right, it's a graphics mesh. Okay, so now all this is yelling about is our, we're not implementing the run function. So function run mute self What else do I need in here? I need, so mute self. We're gonna bring in all this stuff now. So that's gonna be our location from self system data. And we're gonna return nothing. Nothing gets returned. The first thing we're gonna use here is specs join. And now we can loop through and like join all of our location together. So this is gonna be for location in location dot join. So now we have all of our locations. We can go ahead and drink reminder. That's really fast. I don't think I need to drink that often. I mean, I just need to like remind myself to like have it. Also, my fingers are cold, so holding the tea helps warm them up. It's 10 minutes, every 10 minutes. Oh, interesting. Okay, so function run, we have our location. So now we're gonna just essentially move this graphic. So, oh, look at this. Okay, so, well, okay, we're not gonna put it into the new, we have the location. So we're just gonna do what we have here down below. So if I copy you, paste you in here. So instead of graphics, it's going to be, well, no, graphics draw. It's going to be self.context. I think you need to be a reference to it. I don't remember if it's a reference or not. I think it's just going to be self.context, self.baton mesh, graphics draw param new. Our destination is a point to new. This will be from. Our location dot zero. Rotation self dot angle. So I'm gonna have to do 0.0 until we have an angle. And then there's no question mark. So we're just gonna have to unwrap this. Hey, I'm using you. Oh, unnecessary parentheses. Say view. We're running with that. Unnecessary parentheses. We'll be adding those around later as we get more things. So we have that in draw. Instead of view, we're going to create our system data, like our system. So we're not drawing this in the center, so we don't even need that anymore. We're going to use draw system equals draw system. And we need to pass it in context and the baton mesh. So context is going to be, well, just context and then self dot baton mesh. You need to be a reference to it. Expected identifier found. Oh, yeah, context baton mesh colon, like that. And now we're going to run it. So we're going to say draw system dot run now. and pass it a reference to the world, and that should draw it out. No method named runNow for draw system in the current scope. What am I missing? Oh, runNow. I need to bring in runNow. Cannot borrow draw system is mutable, so you need to be mute. All right, let's go ahead and give this a shot. Let's see if it works. All right, so our baton is in a new position. So we can now start like actually rotating around and getting all of the interesting things about that set up. So in the meantime, just one off-topic question. What's my favorite SQL database? Postgres. That's like an easy one. Postgres is my favorite SQL database. Of course, at work I have to use MySQL. MySQL, but it's I just feel like Postgres is really easy to use. They've been adding all sorts of cool features to it. They continue to add cool features to it. It's super fast. And it works pretty much everywhere. So that's it. All right, so this comes here. We can now start adding in all sorts of cool things. We want to get our angular momentum. Like, so we need to set up what we have here. In fact, I'm not going to need, let's see, so this is UI, this is UI, our draw system. I don't even know if we're going to need to care about what's in draw anymore. Now we're going to care about what's in update. So we're going to need to have our angular velocity, our angular acceleration, our angular velocity max. These can all be different things. So close down our draw system. Let's go ahead and create these. Derive component, struct angular. I guess